Okay, before you can like send rockets into space, believe it or not, it's not actually a one-dimensional thing. It's actually a multi-dimensional thing. That said, we're going to start by looking at motion along a straight line, which is all of what chapter 3 is about. The first thing we'll look at here is just motion, displacement, and average velocity. So these are all important words. We'll get to them. I'm going to use the slides as kind of a starting point. We'll see how that works. Okay, picture, whatever. Okay, so so what this slide here is talking about is, and of course you should be reading the textbook as well, but on the off chance that nobody ever does that, um, here we go. All right, so when we're talking about one-dimensional, this just means literally going back and forth. So this person is literally going back and forth. They're not going towards you. They're just going back and forth in front of the chalkboard. Okay, um, if you start here and you go ploopy 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 ploo, and you end up here, your displacement is 0 because that's the distance that you have um, changed from your initial point. So delta, so when we say delta, that means change from initial position or point, or however you want to do it. Now, total distance traveled is going to be, a whole lot because we did a whole bunch. We went to doop to doop to doop to doop to do, but because we ended up exactly where we started, equals, come here, chicken, equals, okay. Well, not really infinity, but a lot. Okay. So that's what we mean by displacement. And this is always positive, and this is always negative. So if I start here and I go shoopy doopy 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 doo, and I end up here, then I've gone like plus, say, 2. If I start here and I go shoopy doopy 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 doo, and I end up here, then my total displacement is minus 2. And I've still got this problem with my pen, which is infinitely annoying. Okay, makes sense? Okay, so that's displacement versus distance traveled. Now, this is what this is talking about. So, timeline of Jill's movement. So, Jill goes all these different ways. She goes back and forth, and then she goes over, and then she goes back again. Then ooh, look at that. Okay, so we can see. All right. So, she's going forward 5 and backward 5, or half. Forward a half, backward a half. Forward 1, backward 1.75. Okay, so that's her position versus time graph. Okay, so the total displacement is going to be this distance here. This is displacement. The total distance traveled is going to be the length of that line. Okay, I don't know if that helps. I don't know. Some people like graphs, some people like pictures, some people like whatever. The thing is, if you're going into like engineering, or if you're going into, well, really anything, physics, if you're going into just physics, then doing all of this in your, conceptual brain head is fine. But if you're going to almost anything else, you've really got to be able to convert the pictures into real world thingies, real world scenarios. So that's something that you're going to see me constantly trying to remind you of. Like, look at this picture, look at what's going on. Now look at the graph. Now look at the picture. Now look at what's going on. Now look at the graph. Now look at the math. Now look at the, having to, or being able to understand everything from all the different perspectives is really important. Okay. So now you're also going to see the average velocity. Okay. So the average velocity, do they have a slope of this? No. Okay. So the idea is, so now I've introduced a new word. So speed, oh, come on, stupid pen. Speed, no, you're just going to do this to me. All right, so speed is your, well, distance, I can't spell, distance over time, right? Okay, so if speed is distance over time, that would be like your floopy doopy 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 doopy, all the distances, so like a lot over the time. All right. Now, on the other hand, we also have velocity That's going to be a vector, which we talked about last time. So this is magnitude only. The velocity is a vector. This is displacement over time. So in our example above, it might be just 0 over, time. So if we go doopy 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 doo, and we end up here, our total velocity, or average velocity, is 0. Up above, our average speed might be like a lot. Just depends. So now this one is talking about average velocity, and they're trying to make this connection between the slope here. So if I start here and I end here, bloopy bloops, that's my average velocity. I started at 0.0, I ended up at a position of negative, I can't read, what is that going to be? Negative 0.75. So in this case, my average speed was 0.7, or average velocity, sorry, no, I'm using the wrong words. Thank you. My average velocity is I start where I started, I end where I ended. I started at 0 time, I ended at 50 time, so I have 0.75 over negative 50. So whatever that turns out to be, that's my average velocity in meters or kilometers per minute, or whatever that is. So that's just the slope of a line, right? km per minute. Make sense? So speed, how fast you're going, velocity, ba-doop, ba-doop. All right, let's see what else we have to talk about in this. This one is just, okay, so we're not doing instantaneous yet. All right, so this is just the averaging, and, ooh, okay, now this is going to get to instantaneous. So this dude again, here, if he goes this way and this way, we could say that let's say this takes, there's no information on here, so we're just going to make this up. Let's say this takes 10 seconds, and this takes, I don't know, 4 seconds for some reason. Okay, so if we were going to draw a little graph, it could be like, okay, so he's going to go backwards, 1, 2, 3, over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So he goes backwards, and then he goes in 1, 2, 3, 4, he goes up 1. So he ends up here. Make sense? So the total displacement, so the displacement equals, man, come on, pen. I really did troubleshoot this. His displacement is -1, and his average velocity is -1 over, how long did that take? 14 seconds. So kilometers per second. So, whatever that math turns out to be. So that's displacement over velocity. Now, if it was asking us for our speed, if we were looking for average speed, usually what that means is that we would be going kind of like absolute values. So like instead of -3, we would just say, oh, come on, I really did try to get this to work. -3 plus 2 over the total time. So his average speed was 5 over 14. Let me see, and I can just do that math right quick so we can just kind of compare, what's the word I'm looking for, just with, so this is like, this says he went about -0.07 kilometers per second. He went really fast. Sorry. He's like the world's fastest bicyclist. Okay, and then here he went an average of 357-ish kilometers per second. And this is what happens when you have mathematicians teaching physics, is we make up fake units that don't make any sense. Okay, so that's the difference between speed, velocity. So this would be the total distance, again, over the total time. So those are the things that we're talking about when we talk about distance, time, blah, 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 blah. And these are averages, okay, which is really important because we're about to get to instantaneous, which is how we speak physics most of the time. Most of physics is spoken in instantaneous, whereas in real life, we're used to speaking in averages. Okay, so that's the big flippy dot. That's the big adjustment here conceptually that we're about to start to take.